Okay, I think we're live. Fantastic. It's 2 p.m. right now. We're still waiting on a couple people probably to log in, but I want to be respectful of everybody's time. So, yeah, I think I'm going to go ahead and get started. I'm super happy to be here, guys. My name is Christian Wallace, and today we're going to be talking about Acoustics 101, sound insulation of multi-story buildings. And first off, I'd love to start off by saying thank you for taking some time out of your day. If anybody is logging in from the US, happy Thanksgiving. And for all of us in Canada, well, it's just another Thursday. So happy that you're here. On my side, I'd love to introduce myself a little bit because maybe some of you, or maybe all of you, have never met me or have no idea who I am. So again, Christian Wallace here. I'm armed with a decade of acoustic adventures, and I'm hell-bent on saving building pros from noise chaos and hitting acoustic nirvana, pun intended. So promoting construction acoustics across different types of construction in Canada and the US has really kept me busy. Think conferences, innovation projects, collaboration with industry professionals, and really what I've learned in this past 10 years, paired with Acoustitech's R&D, has really allowed our team to deliver expertise that's really practical and cutting edge. So hopefully today I'm able to bring some brand new information to you so that it could be useful for the projects that you're going to be working on. So again, thank you so much for your time. A couple of notes that I need to make sure that I say here is that you're going to be receiving your certification via ATS within the next 24 to 48 hours, working hours, that is, right? Not from Acoustitech, you're receiving that via one of our partners, which is ATS. So if you see an email from ATS, don't erase it. Just know that that is your certification. Also, another note is that there is a Q&A section on this presentation. However, I don't think we're going to have time to go through a bunch of these questions at the end, but feel free to put down your question, and we are going to make sure that we respond to every single one of you guys once the presentation is over. So within also 24 to 48 hours via email. We have all of your email addresses, so we'll make sure to get back to you as soon as we can. Okay? So now that that's out of the way, let's go ahead and talk about a little bit of who Acoustitech is. I've introduced myself, but I'm also sure that some of you have no idea who Acoustitech is. So Acoustitech started out as an acoustic solution manufacturer back in 2000, so about 25 years ago. But slowly, we became brokers in acoustic solutions. Now, you may wonder what that means. So if you've ever been to our website, you'll notice that there's a lot of different brands in our website. And the reason why is because what we've done is we've gathered the absolute best at what they do in terms of acoustics. So we've gathered many amazing companies across the globe. We brought them together so we can really become, as we can say it, a one-stop shop for acoustics. And we're able to help in a lot of different areas related to architectural acoustics. Now, mind you, we don't really touch environmental acoustics, but we do focus on everything that's going on inside of your buildings, whether it's floor ceiling assemblies, wall assemblies, mechanical rooms, gym floors, and so on. So our goal is very simple, is the right product at the right place. And like I said before, we've been doing this for 25 years. So don't just think that we're an acoustic solution provider. Like I said, we are brokers of peace and quiet, and our mission is very simple. It's about keeping it simple, positioning the right product at the right place, and making sure that the conversation about acoustics is a lot easier. There's a lot of different people sometimes surrounding a project, and acoustics can get a little complicated. You know, architects are going to have, you know, their own opinions, their own specifications. Sometimes you have specifications coming from the acoustic consultants. Then you have the GCs that are involved. You have the installers that are involved. So there's a lot of people around the table, and sometimes it can get quite complicated. So our goal is just to make sure that that conversation flows a lot easier. We're making sure that we're providing the right solutions, hitting the right acoustical targets, and making sure that we're recommending products that are not just performing well, but that are also easy to use, that are going to bring, a faster job site, better sequencing, which are going to result in cost savings. At the end of the day, in buildings, in construction, who doesn't want to hear about cost savings, right? So that's in a nutshell what we do. Now, next up, I wanted to introduce to you the brand ecosystem that we bring to the table. So these are the partners that we have up until today. And we are going to be working on other partnerships as well as we move on into 2026 and 2027. But this is who we are and what we bring as of today. So Acoustic, we are a manufacturer of underlayment solutions. We also have a line of acoustic adhesives and regular adhesives as well for wood floorings as an example and other types of floors. As far as underlayment goes, what I mean by underlayments, these are acoustical mats that are going to be positioned underneath your finished floor, whether it's a ceramic tile, an engineered wood floor, a laminate, or a vinyl as an example. That's how we started out our business. Then we have another partner called Suprema, and I think I'm going to bring a little pointer out here. Next up, we have Suprema. Maybe many of you have heard about who Suprema is. They're very large in everything that revolves around waterproofing and roofing materials, but they do have an acoustics division that is absolutely fantastic when it comes to wood frame construction. And Acoustic handles their division across Canada and the US. Next up, we have Fermacell. Fermacell is a beautiful company based out of Germany. They specialize in acoustic solutions, which have as a main purpose to move away from wet topping solutions. What I mean by that is, oftentimes in wood construction, light wood frame and mass timber, people are going to be using 1.5 inches or whatever thickness of a wet topping, like a gypcrete topping as an example. However, in these types of builds, there's a lot of people that are looking for alternatives because of maybe they want to save time, they want to save on weight, they want to reduce embodied carbon, and I'm going to talk a lot about that later as well. But just know that Fermacell has products specifically made for that. Afterwards, we have Rothoblast, which is a company based out of Italy. They also specialize in wood construction, most particularly in mass timber construction. They are going to have anything related to connections for mass timber, products to protect your timber, but they also have an amazing division of acoustics, which we take care of and have a lot of different purposes. Flanking noise control, impact noise control, and so on. Next up, we have PAC International. PAC is a company based out of Portland, Oregon. They are masters at acoustical clips. Anything that you can think of that could hang from a clip or that can be attached to a wall, that's what they do. Basically, they have over 100 different variations of clips that can be used on ceilings, mechanical spaces, they can be used on walls, and this all to improve your acoustic performance. But not only do they focus on good performance, they also focus on products that are easy to use. That is what's made their company shine against competition. Artopex, they specialize on creating mute boxes. So basically small booths where you can have a one-on-one meeting with somebody and it's completely soundproof. We're seeing more and more of these types of spaces in large office areas and things like that. So next up, like I said, collaborative approach is what we do. We deal with all these different types of building professionals. I spend my days working with architects, builders, developers, GCs, installers, and so on. So if any of you after this presentation would like to talk to me, more than happy to connect with you and obviously help you out with your projects. A couple of things that make Acoustic different, guys, is the following. So we really have built a specialty revolving around floor ceiling assemblies. We have over 400 different products that we can bring to your projects. Obviously, we're not going to talk about them today, but just know that we have a big database of products. Also talking about databases, we have over 3,000 acoustical tests in our database, which means that we're not only recommended products that we think are going to perform well, is basically recommending products that we know perform well because we have tested them over and over and over again. So we have tests that we have done in laboratories. We have done field testing as well on a lot of these different products. And as an example, one thing that we are very well known for in the marketplace is our knowledge of the flooring industry and the performance of different types of floors. Sometimes people wonder, well, Christian, how is a laminate floor going to compare to an engineered wood floor? Or is a glued installation better than a floated installation for my wood flooring? We have tested all of that over and over again, and we have those answers for you, which is pretty cool. So up until now, we have completed over 800 plus projects across North America, which we are very, very proud of. All in all, these are all the challenges that we can help you solve. Like I said, floors, ceilings, walls, gyms, stairs, garage doors, mechanical rooms, drainage pipes, anything related to flanking noise, impact noise, mechanical noise, and airborne noise. We can be the person that can help you throughout these challenges. Now, what I'd like to do before anybody starts falling asleep, it's the afternoon, it's Thursday, I know, but what I'd like to do right now is do a quick little exercise to just see how good your hearing is. Now, I'm sure many of you have headphones on, so for those that do, please turn your volume down because you're otherwise really going to hate me, okay? So, again, for those that have headphones, please turn your volume down and then readjust, okay? So I'm going to play 4 different sounds. The first one should be able to hear it. Now, I have no way of knowing who can or who can't hear. So if you like to react, you know, you have a little section up there where you have like a happy face with a reaction. If you want to put a thumbs up, if you can hear it, or a happy face or something like that, that'd be fantastic. At least it'll let me know that there's a lot of people that can hear the sounds that I'm, you know, putting on right now. So the first one, just so you know, everybody should be able to hear this. I'm going to play just for a few seconds because it is very, very loud. So I'm going to start in 1, 2, 3. Aha! A bunch of thumbs up. Love it. Love it. Love it. Don't hate me if your volume was too loud. I'm sorry. I apologize. But it's going to get a little bit better. I promise. Now, example number 2. If we have anybody that's under 50 years of age, you should be able to hear it, okay? Because there's a big influence between the age that we have and what we're able to hear. Also, maybe you've been to too many concerts, too many Metallica concerts, so maybe your hearing is a little affected. But just know that if you cannot hear these sounds, it doesn't mean you have a problem. This has no medical background whatsoever, okay? So I don't want to alarm anybody here. So I'm going to go ahead and play the second one just for a few seconds again. 1, 2, 3. Give me a thumbs up if you can. Okay. Nice. Love it, love it, love it. Okay. Some surprise emojis here, I see. Fantastic. Okay. Now, on the third noise, I'm sure we're going to start losing some people. Okay. So be honest. If I don't see any thumbs up, that's okay. But if you do, put it up. Okay. 1, 2, 3. Oh, okay. Got a bunch of young people here. Amazing. Has nothing to do with your age, really. There's some research that points out that the older you are, the less you're going to hear. But I have, you know, sometimes 70-year-olds, 80-year-olds that hear better than me when I'm doing these exercises. So, and then last but not least, the one that is under 30. I personally cannot hear it, so I cannot even tell you if it works or it doesn't, but I'm going to go ahead and play the entirety of it. And if you can, I'm really going to be surprised. 1, 2, 3. Oh, really? No way. Okay. You guys are awesome. I'm going to play that again. I can't. Honestly, I'm trying, but I can't. Okay. Well, that's amazing. So either everybody is super young here or everybody's got amazing hearing. So good for you. I just thought I'd include this little example here, guys, because everybody's hearing is different. And what I wanted to also express here is that there's a lot of people that are all of a sudden moving from a single family home to a condo building. And everybody's hearing is going to be different. Their tolerance to noise is also going to be different. So sometimes you can design and build a building to the right standards, but sometimes you really have people that are not used to living with others and are going to be bothered by any type of noise. I'm sure that anybody here that's lived in a condo building has heard stories about people complaining about noise. Sometimes people are just really sensitive to this. So thank you for participating. That was really cool. Now, I wanted to talk about acoustic code requirements before we get into the more technical things so that everybody understands these ratings to get started. So I'm sure you have all seen these ratings at one point or another. Starting off by STC. What is this? What is it? What does it do exactly? So this is a rating that is going to measure airborne noises. You know, music, television, a dog barking, for example. These are all going to be airborne noises, obviously, that travel through the air and that are going to be measured with what we call an STC rating. STC stands for Sound Transmission Class. Okay. Now, what's really important to know is that in Canada, there is a minimum requirement by building code to respect in residential buildings, which is STC 50, as you can see right here. Okay. Now, there's going to be two types of ratings that you're going to see from time to time. You're going to see STC, but you're also going to see another rating called ASTC. And I think it's really important for you to understand the difference between both. The difference is how the assembly or how a certain product was tested. Okay. An STC rating means that something was tested in a laboratory, in a controlled environment, right? Like a bunker, somewhere like Intertech, where you have no windows, no doors. It's a very controlled environment. Things are going to be very much the same over and over again. And this is how you obtain a laboratory test, which is going to be rated with what we call STC. Now, you're also going to have ASTC ratings, which mean that these are going to be tested in the field. Okay. Now, the difference between a laboratory test and a field test is the vibration and the energy that you're measuring. When you are in a laboratory, the only thing that you're measuring is the direct path of how a sound is traveling. As an example, from the floor ceiling assembly or from the wall assembly. The only thing that you're measuring is how that sound is traveling directly. Okay. You're not measuring how that sound is traveling through all the alternative places. Okay. So basically here, when you're doing a field test, you're not only going to be measuring that direct path, but you're also going to be measuring all the alternative ways of how that sound is traveling. Okay. So through the floor, through the walls, and also maybe through an electric and plumbing pipe, through air vents, and so on. Okay. So because of this, building code in Canada accepts a decrease of 3 points. Okay. So basically, if you're testing in a lab, minimum requirement is STC 50. But if you were to test in the field in an actual project, they allow for a 3-point decrease because they consider that because of all these other areas where vibration can travel, you will most likely lose a few points. So if you were to test your floor ceiling assembly or your wall assembly in the field and perform at 47, you would still be deemed code compliant. Now, very important to know, this is for Canada. Now, if you're in the US, US building code allows for a decrease of 5 points. Okay, so to sum it all up, when you're testing in a lab, is STC 50, and when you're testing in the field, if you're in Canada, is ASTC 47 or ASTC 45 if you're in the US. And A stands for apparent. And the only difference is when you're testing in the field, you're also measuring flanking. Flanking means all the alternative paths of how that sound is traveling. Okay, next up is going to be impact. Okay, anything that has a direct contact with the structure is going to be considered an impact noise. walking, running, moving furniture, dropping something on the floor. These are all considered impact noises. And these are going to be rated with what we call an IIC rating, which stands for Impact Insulation Class. Okay. Now, in Canada, there is no requirement for IIC, meaning that not a lot of people are going to focus on impact. And that is very unfortunate because in the US, as an example, they do have a requirement for IIC, which is an IIC of 50, basically meaning that they put as much importance on impact performance as they do on airborne performance. And for any of you here that have lived in a condo at some point or in an apartment building, I'm sure you can attest to this, that 80% plus of the complaints or noise that happens is related to impact noises. Oh my God, I can hear my neighbors walking around. Or, oh, I can hear their kids dropping their toys on the floor. Or I can hear somebody moving furniture at 3 a.m., right? So the reason why I'm saying this is that even though, if you're in Canada, even though a IIC is not regulated by code, it is extremely important that you give it as much attention as you do to STC, because people that are moving into their new condo buildings that are paying a significant amount of money for, they don't know anything about impact. They don't know anything about building code. But if they are in a space that is not comfortable, believe me, they're going to pick up the phone and call somebody to complain. And that's where lawsuits happen. That's where we've heard about horror stories where builders did not address impact. They've had many complaints in their builds. They've had to go through lawsuits. They've had to go back in, move everybody out, rip their floors out, and start all over again because they did not address impact. Now, what do we recommend? We always recommend aiming, designing, and building for a minimum of IIC 55. And why do we do that? The reason why we do that is because things on site don't happen as as well as we all hope, right? Once things are starting to get installed, they're not going to be installed the way we always hope that they do. Things are going to change, the environments are going to change. So by aiming for a 55, if you happen to lose a few points because of installation, you're going to still end up with a building that is going to perform over a 50. And I'm going to have a couple of noise examples to give you a comparative of a 50, a 55, and a 60. So you can actually hear the difference between all of those ratings. Okay. So all this just to recap. IIC is tested in a laboratory. Just know that there is also an AIIC rating, which stands for Apparent Impact Insulation Class, where flanking is measured. The only difference is that this was tested in the field, okay? IIC, tested in a lab. AIIC, tested in the field, okay? Where not only the direct impact was measured, but also all the alternative ways of how that noise was being transferred, okay? As you can see on this example right here below, this is showing you how we perform a test for impact in any type of setup, whether it's laboratory or field. You're going to have a tapping machine with a bunch of hammers underneath and a microphone down below that is going to pick up on those noises and then provide us with a bunch of numbers that then we calculate, and then we get our rating for IIC, okay? Or AIIC if you were tested in the field. Fantastic. So here, guys, I wanted to share with you the comparison of a field and a laboratory test. And one thing that comes up very, very often, which is acoustic underlayments and the high ratings that sometimes are attached to these acoustic underlayments. As an example, when I go and see a client, very often the first question that comes up is, well, Christian, what's the rating on your underlayment? And although that is a fair question, it's a question that has many possible answers because it all depends of where you're going to be installing it. Are you installing this on a concrete structure? Are you installing it on a mass timber structure? Is it light wood frame? Is it steel? It all depends on its environment. Also, something that happens to me very often is sometimes clients are going to say, well, Christian, why would I spend, X amount of money on these underlayments when I can go to Home Depot and buy this very inexpensive foam product that is giving me an IIC of 72? If in your mind you say, well, if building code recommends an IIC of 55, and I can get a product that performs at an IIC of 72, we're golden, right? We're much, much over the recommended minimum, right? However, you need to find out how that product was tested, because it's not just about the number, it's about how they got to that number. So let me explain very quickly here. So basically what we did is we have the exact same floor, we have the exact same underlayment. Flooring was a laminate floor, and underlayment was one of our textile underlayments. The concrete slab was the exact same thickness, 8 inches thick. Okay. And here's the results that we got. We did a test in the field, so in an actual project, where there was no suspended ceilings, of course. It was just drywall attached to the underside, as what we see most commonly. And it performed at an AIIC of 52, okay? Which is a good performance. Don't get me wrong, it's a good performance. However, what we did to compare is we took that same flooring, that same underlayment, same thickness of concrete, but we added a suspended ceiling and we tested it in a laboratory, in a controlled environment. That same product performed at an IIC 72, okay? About a 20-point difference. And this all because the elements changed, right? We added a suspended ceiling here on example number 2. And that's just how much the assembly can influence your end result. So what I'm trying to say here at the end of the day, guys, is don't get swayed by these high numbers. If you see a number that is too good to be true, to me, a number that's too good to be true is anything over 65 STC and IIC. You need to try to figure out how that product was tested and if it actually applies to your project, because you can be using a product that you thought would perform at a 72, and then when you end up using it in your project, it'll perform maybe in the low 50s, maybe even below 50, right? I've seen products that are very thin, very inexpensive, show or advertise numbers as high as 80, which to me is completely insane because they're not giving you the full picture. Okay. So that's why, acoustical engineers are going to come into play. That's why us in our team of experts are going to come into play, because anything that we're going to recommend, we're going to make sure that it applies to your project. So at the end, just remember that the result comes from the entire floor ceiling assembly or the entire wall assembly, if that's what we're testing. It doesn't come from a single product. It comes from the assembly. Okay, so I've spoken about testings, and what I would like to do here, guys, is show you a video of how an impact test is done in the field. So I'm going to go ahead and play that right now. Okay, so what you guys just saw was an impact test in the field, basically measuring AIIC, as you can see right there. And The microphone below is picking up on all those noises. The way we do this is we're going to have that tapping machine on a bunch of different settings. We're going to go in the corners of the room. We're going to go in the center of the room. The same with the receiving unit, which is right underneath with that microphone. And believe it or not, a microphone like that costs around $20,000 to $30,000. So it's a very fine and expensive piece of equipment that I don't know how to handle. I do not touch. I leave that to our technical specialists because I don't want to have to pay it back. It's extremely expensive. So as you can see here, we tested everything. We tested the flooring, we tested the underlayment, we tested the structure, and everything in between. And that's how we obtained our result. The result didn't come from just testing a single product. It's a test and it's a result from the entire assembly. Okay, moving forward here. Okay, there we go. Excellent. So I wanted to talk about propagation of noise in different structures. Now, I know we have a lot of different people here in the audience. Maybe some of you are working more in concrete builds, light wood frame, mass timber, and are interested about different types of topics, right? So I'm going to try to cover all those three. Starting out by concrete. Okay, when it comes to concrete, I think everybody's used to dealing with concrete at some point or another in their career because it's something that is very prevalent, especially for, high end, not necessarily high end, but just high rise buildings, whether it's apartments and condos. We're going to be dealing with a lot of concrete. And often the popular opinion is that concrete is great for acoustics, right? I hear that all the time. Christian, our building is concrete. We're good. We're good for sound. And although that is a statement that has some truth, it's not 100% accurate. So let me just try to explain here. A concrete building, I'm going to try to bring a pointer out here. A concrete building has a lot of mass and it has a lot of weight, okay? The more mass and the more weight you have, the less air sounds are going to go through. By air sounds, I mean music, television, me talking, for example. These are sounds that are going to simply be blocked by the sheer mass and weight of your structure. So, to give you context here, an 8-inch concrete slab on its own, naked concrete slab, no flooring, no underlayment, no ceiling below, nothing like that, tests at around STC 55 on its own already. What does this mean? It means that an 8-inch concrete slab by itself is already code compliant, okay? The fact that you're adding an underlayment or a flooring is not gonna really affect your STC performance. Why? Because it's not adding that much more mass or that much more weight, okay? The purpose of an underlayment is to separate materials. The more separation you have between your materials, the better your separation is, or your decoupling is, as you can see here, the better your impact performance is going to be, right? So, Acoustics 101, which is very simple. The way you control airborne sounds is with the mass and the weight of the structure. And the way you control impact noises is by separating your materials with the right acoustic solutions. So, to give you some idea of how an 8-inch concrete slab performs on its own for impact, it's going to perform around IIC 30 to 32, okay? Nowhere near building code requirement for the US of 50, or nowhere near to the minimum recommendation of Canadian Building Code of IIC 55, okay? 30 to 32. That is terrible performance. So the one thing that you need to remember is that there's only one place you can do things right, and that is underneath your finished floor by using the right underlayment, okay? Now, there's a lot of different types of underlayments out there. There's going to be corks, there's going to be rubbers, there's going to be foams, and there's going to be textiles. Acoustic specializes in what we call thermoacoustic non-woven synthetic fibers. So essentially, it's a very long word just to say that we specialize in textiles. And the reason we decided to, even after 25 years, to stick with textiles is because they are the best material for concrete buildings. And the reason for that is because these materials are the ones that are going to behave the best at controlling high frequency noises. That's what we have in concrete buildings. We're going to have a lot of high frequency noises, very high pitched noises. If you've ever been to a concrete building and you've dropped something on the floor, you've noticed that you have a very high pitched noise as opposed to wood. You know, when you're walking on wood, you have those thud, boom, boom, hollow noises, which are low frequency noises. And you're going to need other types of materials to control that. So in concrete buildings, I'm sure you've all noticed that many years ago, there was carpet everywhere. Any apartment building or condo building, or especially hotel that you were going to, there was an abundance of carpet everywhere. And not just because, yeah, it was trendy, you know, it's a comfortable product. It's still pretty popular out there, but it was the absolute best floor covering at controlling impact noises. Still to this day, there's no floor covering that is going to be better at controlling impact than a carpet. Okay, so essentially what we thought about was, well, why don't we bring the same qualities or the same positive values of a carpet and use them right underneath our floors? So that's exactly what we do with these thermoacoustic non-woven synthetic fibers. So they are synthetic fibers, meaning that they're not going to rot, they're not going to change through time, and they're going to be very, very stable. So why is this product very popular, and why are people shifting from other types of underlayments to this? Is for these reasons, right? One, the acoustical behavior is the best out of them all. Out of cork, out of rubber, out of foams, textile proves time and time again that is the best for concrete buildings. It has thermal properties, it has mechanical stability, has elevation, it has a really low environmental impact, meaning that we have synthetic fibers that are completely recycled, that are going to be completely green for those builds that are trying to achieve, you know, green certificates or LEED certificates and things like that. Also, practicality. I cannot tell you how many times I have dealt with installers complaining about the fact that a cork or a rubber underlayment can be extremely, extremely heavy. And I'm just not just talking about a few pounds, I'm talking about rolls of rubber that can weigh over 100 pounds a roll. Okay, so you can imagine on site when you're installing these products, all of a sudden your hoist is broken and you have to carry these rolls by hand up 5 flights of stairs. It's a complete nightmare. And not everybody thinks about what the installers are living on site. As a comparison, a roll of rubber can be anywhere from 100 to 120 pounds. A roll of textile can be anywhere from 8 to 20 pounds, depending on the thickness. But still, you're talking about something that is significantly lighter, okay? Which means faster execution, better logistics, and just overall a product that is much easier to work. Okay, now I want to touch on light wood frame. Now, when it comes to light wood frame, the very first question that comes up is, can light wood frame be more efficient than concrete? And the answer to that question is absolutely. 100% it can be more efficient than concrete. But there are a lot more areas that you have to think about. Sorry, I'm just going to take a little water here. So I'll just let that sink in. As you saw before with concrete, we only had one arrow pointing at the underlayment. But here we have 1, 2, 3, 4, 5, 6, 7 different areas that can play a part in your end result. So here's what we're talking about. First of all, your flooring. When it comes to flooring, there's a lot of testing that we've done through time, and we understand that even when you're comparing the same floors, as in, let's say, for example, an engineered wood floor, they can be completely different in nature. They can be built differently, their price point can be differently, and the technology behind each floor can be different, although they're both categorized as engineered wood floors. We have seen a difference in performance by up to 5 points when comparing two types of floors, even in the same category. And I'm talking about impact. All these examples that I'm going to show here, they're all related to impact noise. Okay. One thing that a lot of people don't think about is just how much it can help, or it can decrease your performance by selecting the right floor. After that, we're going to have the underlayment. It is crucial that we have the right product as close as possible to the source of the impact. It's the first line of defense. Just think about it that way. By having the right underlayment, you can increase your performance by up to 7 points. After that, you may have a wet topping solution, an inch and a half of concrete or gypcrete topping, which generally speaking gets often used because of acoustics, sometimes because of fire as well, but I see a lot of light wood frame buildings still using wet toppings. People are used to it. People have, just gone around and are used to working with these types of products. However, what you need to know is that wet toppings, what it's doing mainly, it's going to be adding to your mass. It's going to be adding to your weight. And if you remember what I said before, the more mass and the more weight you have, the better your performance is going to be for STC, right? So this is not going to affect your impact performance at all. What is going to affect your impact performance is the underlayment right underneath the wet topping, which can influence your result by up to 8 points. Then we're going to have the cavity space within the joist, right? It can be bad insulation. It can be blown insulation. We've actually done several tests, and we don't really see a significant difference between the technology of insulation. But what is the most crucial is making sure that we have at the very least 50% of that cavity space filled out, okay? Because if you don't, what is going to end up happening is that that cavity is going to react as a drum. You're going to have what we call a drum effect, where any sound that happens in there is going to bounce and is going to get amplified, effectively decreasing your STC as well as your IIC. So just know, for a very minimal investment, try to at the very least fill your cavity at 50%. And if you can do more, fantastic, okay? Because it can really, really make a big difference in your performance. Afterwards, we're going to have resilient channels or acoustical clips. Now, let me say something to get it out of the way first. There is nothing wrong, essentially, about resilient channels. The issue is that 90% of the time, they're not properly installed, meaning that guys are going to go in, they're going to screw in through the actual resilient channels and touch the joist, okay? Effectively, what they're doing is they're short-circuiting their entire system and defeating the purpose of having a resilient channel altogether. Okay, so it's not that it's a bad product, it's just that 9 times out of 10, it is not properly installed. So what do we do instead? We're going to have something like an acoustical clip that completely dummy proofs the entire thing, making sure that those screws do not touch the joist. Effectively, what you're doing is you're going to be separating your entire structure from your ceiling. And as you remember, the more you separate your materials, the better your performance is going to be. So an acoustical clip compared to a resilient channel that was not properly installed, you can achieve a difference in performance of about 7 points for impact, which is huge. You can literally move from, let's say, an IIC 53 to all of a sudden an IIC 60. Now, I've been talking about numbers, right? And I'm going to show you some examples afterwards. But just so you know, 50 is considered only building code compliance, right? It just means we're not getting sued if something happens, but it's not a performant number. It's not considered a comfortable environment. Where you're starting to get some comfort is around 55. That is for your higher end type projects, apartment rentals, condo buildings, hotels. And when you're in the 60s range, that's what we consider luxury standards. So if you're working with a client that is building a luxury build, but excuse me, but is only aiming for code compliance, there's something wrong. Okay, there's something absolutely wrong, because you cannot be building a luxury building and only be aiming for code compliance for acoustics, because the expectation of those units are going to be to not be hearing your neighbors walk on top of you at any given point in time, right? So I'm going to show you some examples later that you're really going to appreciate, I'm sure. Okay, so last but not least, we have the layers of drywall underneath. In the US, generally we tend to see one layer of drywall, but in Canada, it's very usual to see two layers of drywall underneath. Now, if you remember what I said before, the more drywall you're going to have, obviously the more mass you're going to have, the better your airborne performance is going to be controlled. So, all in all, guys, just remember, if you're doing the right things, you can have a wood frame building perform at 60 plus STC and 60 plus IIC for impact, meaning that we can reach luxury standards without a problem in wood frame. There's just a lot more areas to think about. Now, I did want to touch a little bit on dry solutions and the advantages to dry solutions. And it seems like this topic is becoming very, very popular when we relate it to wood frame construction, especially mass timber. All of a sudden, people are more interested in wood. They want to build more out of wood because it's sustainable. It's a beautiful product, especially in mass timber. Amazing, amazing type of structures that you can see made out of mass timber today. But they still have the habit, or just they know nothing else than wet toppings to use for acoustic control and for fire control. But today, I can tell you, we have been doing this for a long time, guys. We have been using dry solutions in lightwood frame and in mass timber for several years now with amazing, amazing success. We have no clients that have ever told us, oh my God, Christian, you know what? Now that I'm using dry solutions, I regret it. I want to go back to working with concrete. It was so much better. Not a single time that has happened. Now, why? Because wet toppings, although people are used to them, they bring a lot of negatives to your project. Now, I have nothing against concrete toppings, don't get me wrong, but there are a lot of people that are not fully satisfied with what wet toppings have. Basically, one is it's not a very environmental friendly product. If you're trying to reduce the amount of embodied carbon in your building, wet toppings are not going to help you do that. If you're trying to reduce weight in your building, wet toppings are extremely heavy. As a comparison, we're going to have about 20 pounds a square foot for 1.5 inches of concrete topping. If you're comparing that to a dry solution, it could be anywhere from 2 to 5 pounds a square foot. You can compare it and say, well, there's about a 15 pound per square foot difference. Now, that may not seem like a lot, but if you're considering an entire project, just think of it this way. If you're working on a 50,000 square foot light wood frame build, which is not uncommon, and you're reducing 15 pounds per square foot, I'm trying to do quick math here, but that's going to be around 750,000 pounds less in your building that doesn't have a wet topping. So when we say drastically reduce weight, this is what we mean. It's significant amounts of weight. So if we're early in the design, you can literally save costs of structural support materials because you're all of a sudden having a building that is 750,000 pounds lighter, which is huge. Okay. Also, with these solutions, there's no compromise. You can still meet and exceed code requirements for sound, fire, and seismic. We're effectively removing moisture from the building, so you're not having to control humidity, drying time. There's better sequencing on site. You can literally have products that you can put in and start your flooring installation right away. No need to wait whatsoever. So it just makes a lot of sense. So I'm going to go a little quick here, guys, because we are closing in into our hour and I want to be respectful of everybody's time. But I just wanted to show you some examples of solutions that we have tested through time. Here, what you're going to see is a rubber felt hybrid technology, which is made to replace a wet topping. This is completely floated. There's no glue that's needed. It just goes down directly over your substrate, and then your finished floor goes on top. This, in combination with an acoustical clip, where your cavity spaces have been controlled with some sort of insulation, with 2 layers of drywall underneath, we can achieve ASTC 55 plus and AIIC 55 plus, which is not only code compliant, it's actually really good performance. Next up, we have products like this, which is a recycled dried element, which is also floated. Only thing you have to do is glue the joints and fix with some screws or even some nails for a monolithic installation. What is very cool about a product like this is that it's very permissive when it comes to the floor coverings that you want to use. You can use laminates, you can use vinyls, you can even lay ceramic tile on top of this. You can nail hardwood floors through this, obviously, so long as the screws or the nails don't go through the entire panel. Now, something like this, with your cavity space controlled with an acoustical clip, you can achieve results in the mid 50s STC, mid 50s IIC as well. So I wanted to give you or show you a little example here because architects are very good at designing with their eyes, right? They can create amazing renderings of how spaces can look like. But for us that work in acoustics, we always have a hard time figuring out how we can show people what these solutions can do. So what we've done is we've created several sound experiences. You can actually go and experience this yourself on our website. We have a lot of different examples that I'm sure you're going to find very interesting. But what I have here on this presentation is literally the recording of footsteps on a structure that performed at 50, one that performed at 55, and another one that performed at 60. So you guys can live and hear the difference between those three performances, okay? So for all of you that have headphones on or on your computer, you can adjust your volume and hopefully the goal here is for you to see or hear, sorry, the difference between those three ratings. So I'm going to go ahead and play that right now. We're going to do it again. Thumbs up if you can hear it. So there you go. There you have it. To give you a little bit more context here, guys, if you were to listen to a recording of a rating that performed, let's say, at a 50, and another one that performed 1 or 2 points higher, so let's say at a 52, you would not have been able to notice it with your ears because 1 to 2 points difference is rarely noticeable with our human ears. Where we're actually able to see or listen to a difference in performance is when we're starting to get to that 3 to 5 point mark. And not only is the sensation better, we have actually calculated that the sensation is doubled. So moving from a 50 to a 55, it's not, oh, it's a little bit better. It's actually twice better. And the same thing goes for 55 to 60. So hopefully, guys, this was able to show you how a 50 rating is not great. You know, you're actually able to hear people walking on top of you. At a 55, you were maybe able to hear a little bit here and there. And at a 60, you know, it's very minimal. You really have to be in a situation where somebody is really trying to annoy you in order for you to be able to hear that. So hopefully this will give you some inspiration for your future projects where you say, hey, you know what? Let's aim for a minimum of 55, or why not? Let's go and hit a 60 because this is a higher end build and these are going to be the expectations from our clients. Okay, so mass timber, guys. Now we don't have a lot of time left, but I'm going to try to give you as much as I can about mass timber. So when it comes to mass timber, it's really a type of structure that is gaining a lot of popularity, both in Canada as well as in the US, because it's beautiful. It's a great product. It can, you know, you can really build fast with these types of structures, but there's a lot of challenges when it comes to acoustics because we're dealing with something that is significantly lighter and prone to vibration. Okay. So here, what I'm going to be explaining to you is the challenges that comes with mass timber. First of all, like I said, lighter product, but also 9 times out of 10, people want to have those ceilings exposed, effectively removing one area that we can play with. It's a beautiful product, right? You want to see the timber. So the only area that's left to play with is on top. Okay. So we have to get really creative with the solutions that we have for mass timber. But at the baseline, let me show you where we are. Okay. An 8-inch concrete slab on its own is going to perform between 28 to 32 for impact. Okay. Now, when you're comparing that to a 5-ply CLT, your impact performance is going to be between 21 and 23, at least a 7-point difference in impact, right? Now, the biggest difference is on airborne. An 8-inch concrete slab, like I said before, is already going to be code compliant on its own at around a 55 plus STC. A 5-ply CLT on its own is going to be around 39. So about a 16-point difference, which is huge. Okay. So by nature, they're very different products and we have to treat them differently. If you have a project that you're working on that is mass timber and you don't mind hiding the ceiling and you are working with a suspended ceiling, just know that with a suspended ceiling and the right acoustic solutions, you can achieve ratings around 60 STC and 60 IIC. But 9 times out of 10, that's not the case. When you're working with wet toppings and with some sort of rubberized material, like in this case, and underlayment with a flooring, exposed ceilings, we can be code compliant. Okay, we can achieve around 50 STC and 50 IIC, but this is not your luxury type build or your high-end type build for this matter. Okay, now we do have solutions that are going to be completely dry as well for mass timber. No need for any wet toppings whatsoever. This product is also one of the only solutions that is going to have a Type X certification on it. So if you're working on buildings that are going to be over 8 stories where you need encapsulation requirements, you have products that are dry that are able to comply with that, achieving ratings that are going to be building code compliant, IIC 50, STC 50, with no suspended ceilings whatsoever. But what if you want to kick it up a notch? We have solutions out there that are going to be like these lightweight acoustic panels. There's actually a video of a job site that we did in Brooklyn, New York. These are going to be panels that are going to be a little bit more engineered. You're going to have panels that are going to be 1.5 inches thick, sitting over a textile underlayment, 2 layers of plywood on top, and then your finished floor. In this case, it was a hardwood floor. No suspended ceilings, so everything was exposed. We were able to achieve 55 plus STC and 55 plus IIC. Really, really good performance for an assembly without any wet toppings. Recently, we have added to this another product which we call a discrete isolator. We have tested over a 5-ply CLT without any suspended ceilings. We have fiberglass running between the isolators, 2 layers of plywood, our underlayment, and our finished floor, which was a laminate, and achieved results of STC 60 and IIC 64, which is luxury standard type of rating. So even if you were working on a hotel that is going to be high end, you can do that, but you need the right solutions and the right guidance. So guys, I think I'm going to blast through this section. I've already mentioned a lot about floor coverings. And just know that we have a lot of different studies on our website that you can go and access. We have studies on mass timber, studies on glulam or GLT that we recently did. We have studies on ceramic tile, tested a lot of different types of underlayments and acoustic solutions underneath tile. It's just that tile is very complex and it has a lot of challenges when it comes to acoustics, but we've tested a lot of different things and we're able to help you through that. We have also studies comparing rubber to textiles. We have anti-fracture membranes and so on. So just know that there's a lot of resources on our website. I'm not going to go through our case studies, but just know that there are a lot of case studies on our website. There's a section specifically called case studies. If you want to go and take a look at those, see projects that we've worked on, learn about the challenges that we faced and how we were able to correct them, go ahead and do that. Also know that we have our Acousti Index section, which literally is a tool that is completely free for you guys to use, where you can go, you can select your structure, you can select your assembly components, you can select the type of floor that you're going to be using, and live, you can get an idea of how that assembly is going to perform with more details, all the materials that were used, and us as a resource to provide any additional data that you may need. So guys, it is officially 3 o'clock. I really want to thank you for your time. If anything that we said today makes sense to you guys, we would love to hear from you. You can schedule a call with me or with one of our experts. We can take a look at your plans, review these projects with you. We can provide custom recommendations to you, and we're all about collaborating with you guys and making sure this is a success. So I really want to thank you for your time. This is my information here. You have my email, you have my phone number, and you can also scan my QR code here if you wanted to get my information directly on your phone. Again, thank you so much. For any of you that put some questions in the Q&A section, I'll be more than happy to answer those afterwards. And yeah, just remember, you'll receive your certification within 24 to 48 working hours through ATS. So again, thank you all very much and hope to talk to you soon. Take care.